All right, let's take a look here at an example from, this was section 3.2, I think, the factor and remainder theorems. So the thing that we're going to use here, well, let's read the problem first. So find a polynomial function with integer coefficients. This is going to be a big deal. That has real zeros, this one and this one. So we've got two zeros, and we want to construct a polynomial that has those two zeros, that has integer coefficients. Okay, so what we're going to use here is that if x equals c is a zero of some polynomial f, then we're going to have a factor here, right? X minus c is a factor of f, right? So if I've got a zero, I can immediately tell you what a factor is. So we can start constructing what our function should look like, right? It's going to be, a product involving a couple things, maybe, maybe some more stuff, but at least we've got two zeros. So I can tell you what two factors are, right? X minus the first zero, 1/2 plus square root of 3 over 2. And then our other zero is going to give us another factor, right? X minus the other zero, so 1/2 minus square root of 3 over 2. Okay, well, if both of these things are factors, that means if I multiply them together, well, that's going to get us rolling on what f has to be, right? So the fact that we have a zero tells us that we have a factor, right? So now we can just multiply these together and we'll see what happens. So let's do that. This might not look like one of those things we would say FOIL for, but it is, right? We've got one term, two terms. So we've got, this is a binomial, if we think about it like that, binomial. And this is also binomial, right? One term, two terms, so binomial. So if we want to treat this like a binomial, we absolutely can, especially if we've got those grouping symbols on there, right? So let's go ahead and treat this like a binomial. And we can use that nice acronym FOIL, right? We got the first terms, the product of the first terms would be x squared. And then we want the product of the outside terms, so that's going to be x here and this one. So if we multiply those together, we would have a minus sign in front, right? We got a minus here. I guess an arrow would be better. A minus sign here and a positive on that one, so the sign's going to be minus. We got x times 1/2 minus square root of 3 over 2. Okay, and now we want the inside terms, so those are going to be this term and this term. So now we've got another negative x and then 1/2 plus square root of 3 over 2. Okay, so it's the inside terms, and then we want the last term. So we got a negative times a negative, which is going to result in a positive, and we're going to have their product. Okay, so now we play the simplification game, and we love the simplification game, right? So we're going to multiply everything out, combine all of our like terms, and we'll see what happens. So we're going to distribute this x through here. We're going to distribute this x through here, and then we're going to do again that FOIL bit with these, right? Okay, so that front term, that x squared, that's going to be our best friend at this point because we don't have to do anything with it, right? But the rest of the stuff, yeah, we gotta do a little simplification. So we've got negative x times 1/2, so we got negative x over 2. Then we've got negative x times negative square root of 3 over 2, so that's plus x times square root of 3 over 2. Okay, now our next one, we've got minus x over 2, and then minus x square root of 3 over 2. And now, I mean, looking ahead a little bit, we can see that these two guys are going to cancel out, and that's going to be super convenient for us. Okay, so now we've got the rest of this. So this part we're going to do, that FOIL bit. So we've got, 1/2 times negative square root of 3 over 2. So that's going to be negative square root of 3 over 4. Then I'm going to have, that's the first terms. And then our outside, wait, that wasn't our first terms. That was the outside terms. Come on. So the first terms is 1/2 times 1/2, right? 1/2 times 1/2 is 1/4. Now we've got the outside terms. So that's going to be our 1/2 and square root of 3 over 2. So that would be negative square root of 3 over 4. And then we've got our inside terms, right? We've got this one times this one. So that would be plus square root of 3 over 4. And hey, look at that. we can see that it's going to work out in our favor. And then we've got the last terms. So we're going to have a negative sign attached to that, right? We're multiplying this guy by this guy. So we're going to have a negative. We're going to have square root of 3 times square root of 3, which is just 3. And then 2 times 2 in the denominator is going to give us a 4. Okay, so yeah, something we noted on our way by is that this term is going to cancel with that term, right? And then this term is going to cancel with this term. So that's awesome, right? All of our fraction stuff, well, not our fraction stuff, but our radicals went away, didn't they? That's great. So let's check out what's left. So our x squared term, boy, I love that term, right? We didn't have to do anything with that. And now we're going to collect everything else. So I've got a negative x squared minus x squared. So that gives or square, that's not a square, x over 2, excuse me. So negative x over 2 minus x over 2. So that's going to be minus 2x over 2, which is just x, right? And we can just write x. And then we've got our constant. So we have 1/4 minus 3/4. So that's minus 2/4. And we know that that's a half, so we can just write a half. Okay, awesome. So at this point, we have a polynomial that has rational coefficients, but not integers, right? So if we don't have integers, all we're going to do is just multiply it by some number. You know, it doesn't matter what number we multiply by it. If I have some number out front here, as long as that's a real number, like maybe 3 or something like that, that's not going to change the zeros, right? And we can maybe see that if we put a 2 in front of there, and if we multiply everything here by 2, well, if I had a 2 up there, is that going to change the zeros? I mean, I've still got this guy as a 0, right? And I've still got that this guy is a 0. If we put those values in for x, we're going to get a 0 in one of those two positions, and it's going to make the whole thing 0. So really, we can just, put that 2 in there all the way down the line. And it's just there, right? So 2, and then if we multiply those through, well, we're going to cancel the fraction out, right? So we've got 2x squared minus 2x minus 1. So here we go. We've got a polynomial function. It's got integer coefficients, and we've got that the required zeros are required zeros. So something that we might wonder is, is that actually good? Are those really zeros? So something we might try to verify. Verify the zeros in some other method, right? We know that if 2x squared minus 2x minus 1 equals 0, if that's going to be true, we can use the quadratic formula, right? X would have to be negative b, so negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Okay, now what happens when we simplify those? Well, we would have a 2 out front, plus or minus square root of, then we simplify the stuff under here. So we've got a 4, right? Negative 2 squared is 4. And then the other part, we would have negative 4 times 2 is negative 8, times negative 1 would be positive 8. And then we got over 4. Okay, so continuing on with the simplification here, we've got 2 plus or minus square root of 12 over 4. And then we can simplify the radical. 2 plus or minus, 2 squared is 3 over 4. And now we cancel the common factors out of all of those. So what we just found here was that the zeros are x equal 1/2 plus square root of 3 over 2, right? If we split up that fraction. And x equal 1/2 minus square root of 3 over 2, right? If we split up that fraction. So, hey, how wonderful. We just verified that the polynomial that we found actually did have those zeros. So that's, we kind of want to be cross-referencing ourselves with all of the things that we are learning. Like we're kind of snowballing a kind of set of tools that we need to be able to convince ourselves that we did it right. And hey, we did it right. All right, so thanks for watching the video. Have a great rest of your day.